Hi everyone, now in this video we are going to look at radar range equation, which is the most powerful and most important equation for determining the range, gain and powers of the radar. Now if you look at the first column or first block, we consider a radar transmitting the power PS towards the target, okay, and the power density, as we know, is given by power by area. Okay, now in this case we consider the waves which are traveling from radar to target are ideal one. Ideal means in this case the waves do not undergo interference. As you can see, the first equation we have taken SU is the PS by 4 pi R1 square Weber per meter square. As you know, watt per meter square. As you know, power is measured in watts and area is measured in meter square, where 4 pi r square is area of a sphere. And this is to be noted why I have considered 4 pi r1 square. When we deal with an antenna, any antenna, we can see that the waves from an antenna radiate in the form of spheres, constant spheres. So we consider the radiated energy might be in the form of sphere, and the area of sphere is given by 4 pi r square, where r1 is the distance from radar to the target. Now what we have obtained from the first equation SU is equal to P is non-directional power density. Non-directional means it doesn't have a particular direction. It spreads over a range of kilometers or something. So to get the directionality, what we do is we multiply it with the gain, which I have done in the equation 2. Sg equal to Su into G, where Su is the same as that one in first equation. So I got PS by 4 pi r square into G. Whereas SE is the received power density. You can say reflected power density or else, because the power at the target is reflected power by the target is P small r, as I mentioned in the second block. So SE will be the power density by the power PR towards the radar with a distance of R2. It is in the third equation. Now in the second block, if you observe that PR, the reflected power, is given by the power density, directional power density into sigma, where sigma is the radar cross section area of the radar. It's a radar cross section area into multiplication of that PS by 4 pi r square, 4 pi r1 square into G, which is, you can observe it in second equation, Sg directional power density into sigma. Now PE is the received power at the radar. It is given by power spectral power density SE as it is in the third equation here, and in the product of effective area A, where A is K into A, where capital A defines the actual area. It is multiplied by a factor K, which might be a 0.6 or 0.7, but we take it as a constant actually. So I took AE is the effective area, A is the actual area, Ka is a multiplying factor. Okay, now substitute AE in P equal to SE into AE, we get fifth equation. Thereby now As we know from 3, SC is this, so substituting it in PE equation, we get the equation number 6. Now when we go and substitute this fourth equation PR, P small r, in the sixth equation, we get P equal to PSG sigma AK by 4 pi square R1 square R2 square. Now as you can observe the figure, the distance from the radar to the target or target to the radar is almost the same. R1 is more likely to be R2, and we consider R1 R2 to be some R. Now as you can see in the denominator we have 2 squares, then R becomes the fourth power, that which I have done in the seventh equation. Now gain is given by 4 pi by sigma lambda square into effective area. As I already mentioned, A equal to K into A, there I did not mention 4 pi AE by lambda square. This is given by the antenna properties, if you remember. Now substitute 8 in 7, we get P equal to PSG square by sigma lambda square 4 pi cube R to the R power 4. Now cross multiply R power 4 there, P to the denominator, we get R equal to fourth power of PSG square sigma lambda square 4 pi whole cube by P. This is actually the range equation for a radar. Now most of the times we encounter maximum range. For the range to be maximum, now if you can see the under the root, what all we have is G, gain, sigma is a constant, lambda is a constant, G is a constant, power PS, the transmitted power, is also a constant. What is that which will be changing in order to get the radar range maximum is only PE. What is the PE? Received power. It is not going to be the same for all the cases. It might vary. So for the range to be maximum, the power received to be minimum. That is the case, no? When there is a numerator by denominator, for the fraction to be more, denominator term should be less. So I hope you understood how the range equation is got and how it is derived here. Thank you all.